Hey everybody, welcome back to Adventures in Machine Learning. I'm one of your co-hosts, Ben Wilson, and I'm joined today with my other co-host,
Michael Burke. Hi everyone.
And today we're going to have a bit of a chat on production ML infrastructure by way of talking through a couple of case studies. So what were the stuff that you wanted to talk about today, Michael?
Yeah, so today we're going to be focusing on recommendation engines. Both Ben and I have worked to some degree in this area. They're ubiquitous in a lot of industries, and sometimes they're the bread and butter and the core of specific companies. So if you think about Coursera, for instance, when they need to surface content to given users, that is all recommendation. Likewise, Netflix, when they surface movies and TVs to users, that is all recommendation engines. There's not little people in your computer recommending content. It's actually an algorithm. So today we're going to be talking about a couple of case studies. There's tons of variety in industry on how these problems are approached. And so we're going to start small and start working our way up, and then maybe get into big bad hardware, maybe not. We'll see where the conversation goes. Sound good, Ben?
Awesome.
Cool.
Hey folks, this is Charles Max Wood from Top End Devs. And lately I've been working on actually building out Top End Devs. If you're interested, you can go to topenddevs.com/podcast, and you can actually hear a little bit more about my story, about why I'm doing what I'm doing with Top End Devs, why I changed it from devchat.tv to Top End Devs. But what I really want to get into is that I have decided that I'm going to build the platform that I always wished I had with devchat.tv. And I renamed it to Top End Devs because I want to give you the resources that are going to help you to build the career that you want, right? So whether you want to be an influencer in tech, whether you want to go and just max out your salary and then go live a lifestyle with your family, your friends, or just traveling the world or whatever, I want to give you the resources that are going to help you do that. We're going to have career and leadership resources in there, and we're going to be giving you content on a regular basis to help you level up and max out your career. So go check it out at topenddevs.com. If you sign up before my birthday, that's December 14th. If you sign up before my birthday, you can get 50% off the lifetime of your subscription. Once again, that's topenddevs.com.
So case study number one is a shameless plug for something not shameless, a proud plug for something that I've been working on for a couple years now. I've been working with a tutoring nonprofit called Learn to Be, just volunteering some of my time. What they do is they provide free online tutoring to underserved kids in America, so homeless kids, foster kids, and just generally low-income families. And we've grown like crazy over the past couple of years. If you're interested in joining or at least working on something, reach out. But currently, they're a team of about 10 people, and they don't really have ML engineers. We have some BI people, some SQL writers, some dashboarders, but no ML engineers. So we're going to be looking to develop a recommendation system that pairs students with tutors and tutors with students. And so we're looking to develop the first prototype and then put it into production. So Ben, where would you start?
With asking all the about what data do you collect on students and what data do you collect on tutors? And then also any ancillary data that might be relevant to that. Is it a face-to-face interaction? Is it fully remote? What is the nature of the model of operation? And once I got that understanding of whatever it may be, then start thinking about, is there a set of rules that is used? Like, how do people pair people up right now? And once I get that explanation and ask the probably annoying level of hundreds of questions about that, I would, before I start thinking about any algorithm, even any design work of what does that infrastructure need to look like to support that use case, I would ask whoever leads the group, or whoever is most interested in making this happen, I would just candidly ask them, what will make this project a success? And that's my go, no go on any project that I work on. If somebody says, we're doing it, like, we want to do this because our competitors do it, or we heard this is a cool thing to do, then I start down the path of trying to convince them that, hey, this is probably not a good idea. But if they have something in mind of a business goal that says, well, we want to increase the success rate of this mentoring program. What do they mentor about again?
Just basically K through 12 tutoring.
And do you get like report card grades quarterly from the people that are getting tutored?
Nope.
Okay. see if somebody could create a dashboard that allows the students to put in what their performance is, or parents to do that, whoever's a guardian, or see if you can pair up with the school to get that data, provided that people sign off on releasing it. Because that's going to be a metric that you're going to use to determine what the success is of that ML problem. That may happen to be the very metric that measures the success of your organization. For a commercial company, that could be profit, sales, number of customers, customer retention, viewership, maybe. But if you don't have that defined as a goal for the project, you won't be able to measure through any sort of testing or evaluation of this project if it's doing what you wanted it to do. Because none of this is free and you have to spend money. Even if you're a nonprofit and you want to do the simplest thing at first, you're still going to be paying money to do all this stuff.
Yeah. So let's answer some of those questions. On the data side, we collect student data and tutor data when they apply. So general behavioral questions, age, gender, what they're looking to be tutored in or what they're looking to tutor. From there, if they connect with the student, we store that connection. And then if they have sessions, we store a bit of session information. But we don't have any dependent variable at the moment. We're working on a pipeline, but at the moment, we don't have a dependent variable like grade improvement. And then that's basically all we have. The connection process is completely online. So a student can go into the portal and say, hey, here's a tutor I like, send a connection request. And if that's accepted, they connect. And then they work out scheduling a session. So that's the baseline data. And then let's say for determining the success of the project, we want to, because again, we don't have grade improvements. We just want to increase connection length by 50%.
So which of the two is a higher count? Is it the students or the mentors?
Can't believe you got to it that fast. So that is the fundamental problem of this. All of the tutors are volunteers. All of the students are people also not being paid. So maintaining the equilibrium between both pipelines is the fundamental problem that we run into. So let's assume that there are more students than tutors because they're receiving the service. Tutors get benefits out of it as well. For example, community service hours, joining a community, giving back, things like that. But it's a lot less tangible than getting tutoring. So let's say there are more students than tutors.
So the thing that I would probably test out first, knowing that you have no explicit feedback on whether a student likes a mentor or whether that interaction was successful or not. I mean, what I would ask the group of volunteers who are doing this organization, I'd be like, can we have something after a session where the user has to give a 1 to 5 rating on the session, or maybe a 1 to 3, like frowny face, straight face, happy face. It's something where we can say, okay, did they feel like they got something out of this? And if you have explicit feedback like that, then that can open rapid prototyping solutions that won't take up too much time and won't be too complex. If you don't have that, or just unwilling to get any sort of feedback from the session, you still have the data, implicit sort of recommendations. And the goal with that would be, as a first stage, what I would try is something like ALS, to say, my users are the students, my items are the tutors. And if I have enough session length data or whatever other metrics you can acquire from that tutoring session, you can convert that into an implicit rating. Say, hey, things are scheduled for an hour. How long was the duration? If it was 10 minutes, then that probably wasn't a very great session. If it was an hour and 45 minutes, maybe that was a really useful session that people were having an intense conversation about some topic that they get something out of. So I would start there and then put it into an ALS model. I wouldn't even start with anything like distributed unless you have just bonkers levels of data and you need to use Apache Spark. But non-negative matrix factor, like standard Python on a sizable enough computer that can handle that inversion. Yeah, I'd probably start there and just see what the results look like and say, all right, I trained the model. I'm gonna now generate recommendations for that's had a tutoring session over the last 2 months. And then say, for the students, what are the top 10 like recommended tutors that the system generates. And you can do it vice versa too. You can say for a tutor, 100 students that this recommends, and check that against historical data and say, and that's a very manual process. There are some algorithms that you can use, like non-discounted cumulative gain, but that's kind of overkill to do that, like to automate that at an early stage when you're just testing something out. But an approach like that, you could probably get a go, no-go estimate on that approach within 2 weeks of work. You don't really have to build a ton of ETL pipelines, particularly for just testing it out. I would time box that. I would say, hey, we're going to give 10 days to this, test it out. If it doesn't work, let's try a different approach. And maybe it's something that's graph-based, where you say, hey, what are the relationships between the tutors based on all the data properties that we can collect about their sessions with different students? And are there relationships between these tutors? Do they have common attributes associated with their behavior? Can we issue some queries? That's a whole lot more work, though. You're now like faced with data or using like graph frames in Spark or something. It's going to be a lot more work.
Yeah, that's interesting that I completely agree with all of that. And you hinted at this earlier to leverage sort of rules, like a priori rules. That's obviously the most efficient, and that's what we were actually thinking about starting with. But you're right that without a dependent variable, it's pretty tough to optimize anything. So we're also working on building out pipelines where we serve questions to students to actually get that information. So yeah, that makes a ton of sense. One question though, you mentioned that there won't need to be a ton of ETL. I would agree 100%. How would you serve these results though? So on the incoming side, you can train something offline, but how would you serve?
Now we're getting into, I wouldn't say it's ETL. Now we're getting into ML engineering and software engineering, where it depends on what the consumption paradigm is. So if you have a recommender model, be it matrix factorization or ALS or whatever you happen to be using, maybe the business model supports something like FP growth, where you're basically market basket. You're like, hey, a student can pick from one of 10 tutors, and then we'll schedule something later on, and it gives their bios or something. Whatever it may be, at the end of modeling phase, you now have to think about, how do we serve those results? What is the frequency that this data needs to be fresh? And really, like, what's your budget? How many times are people going to be hitting this? And that can inform kind of what you're going to be thinking about with these pre-computed values. So if you're getting a couple of hundred hits a day to a website that's serving this up, and you don't have a ton of customers or a ton of users, where you're like, hey, we have like 100,000 users, then just write it to an OLTP database. It's probably going to be the MySQL, Postgres, MariaDB, something that's, if it's free, it's for me sort of thing. You have to pay for the infrastructure to host that, but that can totally handle most of what you're doing. So if you have that website up, your JavaScript is going to be your OLTP database. Say, hey, give me this user ID and give me their recommendations, the most up-to-date recommendations, and serve it as part of the query. It'll be fast enough. And even if a user is waiting, you're not so concerned with, like, there's this psychological aspect to when you're going online, what you're willing to put up with performance-wise based on what you're going to get. So if you're going to interact with a service online that you're paying them money, you expect that thing to be fast, efficient, and just work. You have almost zero tolerance for it to be broken in any way. But if you're going somewhere to gain knowledge or to get a benefit to yourself from somebody else's kindness and altruism, you're willing to put up with some pretty janky, broken stuff. So that's why the SLO or SLA requirement for serving something like this isn't that extreme. Now, if you're a paid company and people are paying you for this service, yeah, we have to talk about it different. You're probably not going to be using, an OLTP database for, serving all of this. You're going to be talking about, hey, we have an SLA budget of 500 milliseconds and we need these served within that amount of time.
Nice. Yeah. One other question is, you mentioned we'll turn this on for 10 days and see if it does better. how would you evaluate without an A/B test?
Without metrics, I wouldn't.
No,
I wouldn't
let's say
even start it without metrics.
yeah, let's say we have some metrics. They're not great, but they're like connection length, average session length, things like that. But theoretically, we would want an A/B test where some get the model and some do not. How would you evaluate it without an A/B test? Because again, we don't have that infrastructure.
Yeah, I mean, you just answered how I was going to answer it. I wouldn't do an A/B test in this case. There's really no point. It's only a potential positive upside of launching this. So it's basically a new version of your service. And you can before and after measurements say, hey, we launched it at this date. We've done thorough testing. We understand what these recommendations are going to look like. And we're going to provide this as the default behavior. But we're also going to put into the code and into our production pipeline a short circuit so that if we start seeing that people really don't like this and it's just broken, we'll have the ability to issue a command or set some configuration somewhere that'll just turn this off. And I would build that solution in the way you rapidly disable this without having to do a production code push.
Yeah, that's a good point. Just keeping it simple. Another alternative is often business data exhibits weekly seasonality. So you can do something like a seasonal decomposition, and that will account for the weekly up and down. So in this case, there's probably more sessions during the week than the weekend. You can also do something where you forecast what the engagement would look like in, let's say, 3 key metrics, and see if the actual metrics are above or below the forecast. Obviously, if confidence intervals are wide, you can't do a ton of inference on that. But that's a good way to account for the fact that we are not comparing 2 identical groups or comparing a prior group with a current group.
Yeah, I would just make sure that everybody's on board with putting the results from that. And one of the ways that you can get those confidence intervals relatively tight is by doing extremely fine-grained back testing evaluation for the cross-validation. So if you're doing an ARIMA model or something, and you can calculate what the projected forecast CI is going to be, the way that you get variance to decrease is by doing wider back testing windows with predicting smaller like future estimates, and then stepping through it could be hourly or it could be daily or something, instead of what you would do during prototyping where you're like, okay, I'm doing a back testing cross validate, let's skip forward every 2 weeks and we'll just estimate how noisy this, and that's what you do during training. But when you want to use it for what you just explained, you would tighten all those down so that you get a large amount of cross-validation data, and it'll take a while to run. But then you could get those estimates, and then you could say, all right, let's just measure this based on the forecast to somewhere. And then every day we're going to compare what the numbers are to it. And if you're like 5 standard deviations above what the forecast projection was going to be, you can pretty confidently state like, hey, this is doing something pretty good. Like people are using this and it's benefiting everything. Hopefully it's not the other way.
Hopefully, yeah. And then one final point on prediction modeling versus experimentation. In this case, we're using an external, well, it's actually an internal, but a finite marketplace where we have a limited resource. And so an example is in rideshare systems, if you have a limited number of drivers and riders, a standard A/B test often is subject to network effects. So in these cases, you'll have to use more advanced methods if you want more like correct inference. It's not often done because they're complex, but something like a switchback test, also called a time split test, is the more statistically robust way to go. But again, if we're an MVP company with 1 data scientist, we don't have that bandwidth. So just a pre and post, maybe with a trend if you're feeling fancy, that's the best solution probably.
Yeah, definitely. I mean, we all, as particularly like ML engineers, want to create robust production grade, like, hey, this is going to work and we're going to be able to monitor everything. And people have that aspiration of a perfect world scenario, and sometimes fully understand. When they read some blog post, they read a book that somebody's written about how this should be done. They don't realize that a lot of those companies that ideal state came out from, they've got a massive infrastructure of humans very talented and very experienced building and maintaining that. It's just, you can only do so much. There's a finite amount of resources at most companies. So as long as you're making that effort and you're using it, data to explain and validate that'll get you pretty far.
Do you like that aspect of the job?
I mean, I don't really do that stuff anymore. I don't know. I guess you could say no, because now I'm kind of moving into role. But I used to really enjoy, that's a really good question, things that I liked about data science work. I really liked creating feature sets. That was something that just fascinated. That process of feature engineering and validating and using statistics to say, is this feature set that's trying to explain this problem, is it going to blow up in my face? And run the experiments and collect the data and see, like, was my idea or the idea of my teammate or the idea from somebody in this other department who just caught me at the coffee machine, 4 weeks ago with this great idea, is that working? That's really exciting to me, like solving the problem. The stuff that I hated about doing data science work was like model tuning, internals of algorithms. It was fascinating to learn how they worked, but it's so boring to me. I know some people like that. More power to them. I just hated it.
That's why you worked in AutoML, to make your job less sucky?
Pretty much, yeah.
Yeah, on my end, I actually really like, I agree with Ben that like hyperparameter tuning is devil work, but I really enjoy thinking about how, when different assumptions aren't met, how bad is that? So for a mathematical proof, it needs to be airtight, and often that's not realistic. So if this little part of the assumption set is not met, how bad is that in reality? Like, I think that's a really challenging and interesting and valuable skill set to have. And it's something that I've been focusing on recently. It's so cool, and it's so hard because there's just not an answer. So
yeah, I'd say, like, aside from my previous answer, the number one thing that I enjoyed the most was collaborating with who thought in ways that that most people don't think. So I liken it to music. I was an aspiring musician before I went down this path of science and engineering. And I used to play a bunch of instruments: trumpet, French horn, mellophone, and piano, and then picked up guitar later on. But
so classical, or what?
So in high school, I played in like 3 different groups, and concert band orchestra is very regimented European classical composition, some 20th and 19th century stuff, but it's all rules and structure, and people aspire for conformity and excellence in execution. And I think of that as certain types of engineering work, where it's just, hey, we're doing this thing and we're doing it really well, and we have these rules and these laws to abide by. And that is interesting, particularly when you're executing with excellence. I think it's fascinating to be a member of a group that's doing that. But then I was also in the jazz band, and when you get into improv time with jazz bands, you have to do structured, regimented, follow the music on the page and what the conductor's telling you. But then when you get the opportunity to do a solo, it's like, hey, here's your key, just go nuts. And you get to see how other people do that. You swap off solos in these songs, and it's incredibly fascinating, that creative approach. So I think of data science work, if you're in the right jazz band, it's like playing great jazz music. If you're in certain data science organizations, it can be more like that classical music. Hey, just play the notes that are on the page and follow the structure of a series of key changes that occur throughout this entire body of work. So I enjoyed the teams that I worked on that were more like playing jazz.
Yeah, I have a colleague that actually calls all one-on-ones jam sessions. It's funny that you say that.
Yeah, it's kind of how it is. Yeah, I would agree.
Cool. That's a really interesting analogy. I just thinking it through, jazz sounds a lot more fun than being a ballet performer where everything is super precise, or being classical. So I think I would agree.
I mean, there's some teams that I've worked with where, and in some industries, you have to do that. Like, there is no improvisation. You're in a regulated industry. Everything that you do, every line of code, every experiment that you run, and it has to be stored and structured in a certain way. And it takes a certain type of person to excel in that environment and perform really well. That person is not me, but I've met tons of people that they from doing that, and they're really good at it. And it's amazing to see what they come up with within the bounds of that. But I've always enjoyed more the startup mentality of like, hey, sky's the limit. Let's figure out a solution here that can solve this problem that is not regulatory terms, but more of budget, time, and energy.
Yeah, following instructions is only so fun for so long. It's really fun to invent, at least for me. Cool. Well, that was an awesome aside, but bringing it back to recommendation engines. So let's wrap up case study one. Are there any guiding principles that you would ensure that you're doing in this MVP startup environment?
Hi, this is Charles Max Wood from Top End Devs, and lately I've been coaching some people on starting some podcasts and in some cases just taking their career to the next level. You know, whether you're beginner going to intermediate going to advanced, whether you're trying to get noticed in the community or go freelance, I've been helping these folks figure out how to get in front of people, how to build relationships, and how to build their careers and max out and just go to the next level. So if you're interested in talking to me and having me help you go to the next level, go to topenddevs.com/coaching. I will give you a 1-hour free session where we can figure out what you're trying to do, where you're trying to go, and figure out what the next steps are. And then from there, we can figure out how to get you to the place you want to go. So once again, that's topenddevs.com/coaching.
The only thing that we haven't talked about that I would make sure was part of this process before it went into what we're going to call production is monitoring the results of the model or the implementation or whatever it is that we're building here. I would want to make sure that we're checking to see if the recommendation was interacted with, was it followed, was it seen, and was it indicative of what we're trying to measure. So if we gave a tutor or a student, hey, select your top 5 tutors that you want to interact with out of this list of 20. Did they pick the top 5? Does everybody always just pick the top 5? Does that mean that our ranking is bad? Do we need to shuffle that around and recommend a number 1 at the top and then 2 and then 3 and then 4? Should we put number 1 in position 7 and put their bio there? And, how are we presenting this data to make sure that we can say which ones did they select and in what order did they select them? Or if it's mostly doing this, like selecting this pairing for them and not giving them the ability to do that, which one of these, if we're getting 20 and we're getting 20 because the probability that that number 1 person is too many students is probably pretty high. So it's going to be based on availability. Well, I would want to make sure that the process is in place for us to capture all of the data associated with that decision when it gets made. Like, why were the other ones not getting selected? Well, the backend query to internal database that the model has no knowledge of, and the data engineering that is coming in for modeling probably doesn't have in it either, because it's some backend transactional database. So the important thing, the TLDR of what I'm saying here is whatever was involved with sending that request out to the end client encapsulates the full decision and events that happened. Make sure all of that gets written back to some place that you can query later on.
Yeah, I would definitely echo that, especially the first step, which is scoping the problem space. You don't know what to track, how to track it, why to track it. If you don't really understand what the user is seeing, what the user is feeling, what the goals of the user are, what the pain points of the user are. And in an MVP environment, often there's not a ton of prior research. So it's really important to get deep into the problem space so you can sort of develop an intuition about how that actually works. Great. So let's move on to the second case study. Prior to starting the podcast, Ben and I were sort of outlining this and figuring out what exactly we would do. And we were talking about Google search. I was really excited about potentially speaking with Ben about Google search, but he said hard pass. And the reason is that it's a lot of their stuff is very proprietary and we don't know exactly what's going on under the hood. And B, a lot of it is just hardware and very low level programming, because latency of the smallest microsecond is the difference between billions of dollars and millions of dollars for them. So instead of going to that extreme, our next case study is going to be something similar to Coursera, let's say. So in this case, we're going to be doing a recommendation engine where the users are looking for courses. So most people are familiar with Coursera, but a given user will log into the platform and be given a bunch of tiles for different potential courses that they could take. So ML engineering, what is gradient boosting, what is XGBoost, what is SQL. And for all of those potential options, we would like to optimize what is shown to the user. And that's the general problem statement. Ben, does that sound solid to you?
Sure. Yeah.
Cool. So starting off with answering some of the questions that I'm anticipating you will ask, let's say that our data set is exactly what you would expect. We have a bunch of prior user data and we have a bunch of information about the content. And then from that, we are looking to surface the best possible tiles of, let's say, the top 20 pieces of content, 3 rows. Where would you start?
I mean, I would probably start where we were talking with the last one as well. After we get the full problem statement of like, hey, what problem are we trying to solve exactly here? How are we going to measure it? What is the expect on these tiles? And, an estimation of how much this is going to cost. After we get through all of that stuff, the business stuff, then algorithmically, we'll be looking at finding some sort of implicit score associated with this content. And that might be, like when we're talking about something of this nature, we could be looking at sort of an extreme skewed problem and of an esoteric nature. And looking at Coursera courses, what is the distribution of, number of courses by topic? And what is in the level of topic organization are we going to be recommendations? And the only way to figure that out is going to be talking to the subject matter experts at Coursera. Whoever's responsible for curating content, I would pair up with them for many, many weeks and involve them in this project as much as possible. Like, hey, how do you organize content? And what do you typically, when you're recommending new content for customers, which there is some people that are going to be doing that, how do they do it? How often do you pick things that they've never seen in front of them to see if they're interested in it? And for some of the extreme esoteric content that might be on there, where it could be courses on something that maybe there's only a couple thousand people on the planet that are really interested in that. How do you find people to if you don't have enough data? If there's not enough users that have interacted with that, are we going to drown out recommendations by just effectively looking at what's the most popular stuff that's out there? And that can inform through weighting of implicit scoring. You can do that pre-model training and see how that affects it, or you can do it through a combination of custom implicit ratings along with post-modeling processing to say, what is the business objective here? Are we trying to increase visibility into new things that people have in the tiles? Are we trying to just push popular things that we think this person's going to like, but they just haven't interacted with yet? That's going to be another set of tiles. Are we trying to recommend, top 3 courses matter? That's all, results from this same model being processed in slightly different ways that we're going to present and, pre-calculate and just present differently on the front end.
You're right. Start asking questions is the key. A good starting place is often collaborative filtering or just pretty, sometimes complex rules that will just recommend X for a given user Y, depending upon distance metrics. You can also use some sort of predictive models. But Ben, you hinted at something that I think is really interesting, which is the cold start problem. So for users or content that we don't have tons of prior data on, so we would have let's say user age or content topic, that's sort of a static field, but we don't have historical performance data from either the user or the piece of content. How would you approach that?
That's a topic that we could probably have 6 entire episodes just focusing on. There's ways to do that vary in complexity, but at the broad possible that I could talk about this, the easiest thing to do is just calculate popularity. If you just want to solve the cold start problem in the cheapest, fastest way possible, get approval from the business on what their build is on popularity. And that varies by industry. We're talking about online courses. Maybe it's a year. Who knows? Maybe it's 6 months. If you're talking about movies and TV, maybe it's 12 hours. Maybe it's 3 days. Who knows? If we're talking about products on an e-commerce website, it could be a week, could be 2 weeks. If we're talking about high fashion stuff, it could be a couple of days. So whatever that threshold is, just kick off a very simple query of your entire customer base. Like subtracting out pre-identified users or agents that are interacting with your platform in a way that it's not like a typical user. So in e-commerce, you can always identify pretty easily who a reseller is. Buying your goods, having them shipped somewhere, and the volume of it is far too much for a single family to use or a single individual to use. And that shipment address may be, typically when you see a reseller, the shipping address is usually a port of call somewhere. So it's being shipped to San Diego or Los Angeles or, Seattle or New York, so that they can be loaded on a container ship and shipped overseas so they can be sold there. You're filtering out behavior like that and filtering out bots. If you're looking at, visitation data, once you get all that screened out, then you just kick off what is the most frequently interacted with item over the last N number of days or hours or weeks or months, and order by that count. And that's your list for a true cold start problem. If you need to fill a recommendation the next time they log in, or, the next time after they do enough interactions on your, and that'll get smarter over time.
Yeah, that's a great point. And often it's important to think about those first few interactions. I've seen many models built on just a day's worth of data, because often within the first day, within the first week, you get a ton of signal about the user, what their behavior preferences are. But starting at zero is really, really tough. And as Ben said, it's often a good idea to take external information and try to leverage that to be predictive of what the user would actually be doing on day 1, day 2, day 7, etc. And it's a problem that I've seen. It's just ubiquitous, because there's a first time for everyone in everything. So having good cold start solutions is a very in-demand skill set.
Yeah, and I've seen people try to solve that. It's usually an organization who tries to solve cold start with an algorithm because they don't have anything else in place and they've never done this thing before, like built a recommender, and they start from day one of trying to use an on-demand LSTM that's going to retrain, and we're going to have, a 10-second asynchronous SLO associated with this. And as it does that retraining, we can just feed in the recent activity into that model, and it'll predict what the next N number of items are. And you see something like that and you're like, yeah, this is pretty cool. It's an interesting science project, but who's going to maintain that infrastructure? How much is that going to cost? How complex is this? How are you going to turn over this model to a new implementation whenever you need to do a scheduled retraining? What does all of that look like? Who's going to build the traffic cutover switch to go to this new infrastructure when you can solve you can solve this problem exactly as after a day of activity. If somebody's really interacting with your site or your service, you can collect enough data to make the recommendation useful. Start cheap, start easy. It's not something that you should be worrying about, really, because the first N number of hours or product, they're not looking at relevancy of recommendations. Usually people don't care. They're exploring. They're checking out, like, whoa, what's on this site? If you're looking at movies, like, oh, what movies do they have? I'm going to click around and search and browse. And you're not looking for you and saying, wow, this thing doesn't know me at all. How does it not know me? Nobody has that expectation. Or if they do, they don't know how computers work.
Yeah, that is unreasonable. If you have that expectation, please change it. So let's say that we have a good cold start algorithm. What or rule set? What actual machine learning models would you use to develop recommendation engines then?
Depends on what data I have. Most of my recommendation engines has been, or advising people on them, has been in the e-commerce space. That's where I find most of the use cases for them. And it really depends on what data people are collecting. So if somebody has the ability to rate something, we'll say, well, let's use the easiest approach for explicit ratings, and we'll use an algorithm that can support that. What they'll find shortly after building their first couple of iterations of that and really looking at the recommendations for individual randomly chosen users is that there's excessive skew in how people rate things on websites, or it's even worse on apps, apparently. And if you give somebody the choice to choose on a scale of, it's always kind of amusing. Like, what does a 4 mean? Like, who? I'd like to go and meet the person that rates things 4s or 6s. Most people are going to say, "Oh, it's a 0, maybe a 1 if they don't like giving a 0, or it's a 5, or it's a 10." So if you give too many options, it becomes a binary selector, or 3 of those are most predominantly chosen. You will have some people that will rate every number on that scale, maybe because they just really want the accuracy they're rating this particular service. So you have a lot of things that are on a 1 to 5 star rating. That seems to work a little bit better than that 0 to 10. But if you look at the actual data of somebody who's been interacting with your platform for long and ratings, you'll see behavior that is consistent over time to that individual. You'll have some people that will always either rate 1 or 5 stars, turn it into a Boolean. You'll have some people that will never give a 5, even on something that they absolutely love, because it's almost like they're emotionally holding out to when something just truly amazing crosses the threshold of their life. That's when they can finally give that 5 star. And then you have another group of people who will only give 5 and 4 stars. So 1 star. So there's ways that you can regulate this sort of scale everybody's rating. And you can take the average score that they give and then standard scale everybody's responses between a 0 and a 1. And then that's their difference of an individual item to their standard scaled score becomes their explicit rating.
Yeah, that's fascinating that you say that. It makes so much sense. I never really thought about it, but you do have to account for the Russian judge that just gives grumpy faces all the time, and also the person that gives a 5 just to click through reading the rating. So that makes a ton of sense. Yeah, awesome. Sorry, continue.
Yeah, I've always found implicit ratings far more powerful, and implementations that use those, because you can't really lie on that data, which isn't to say that the data is always correct. You still have to do some validations. But for the most part, if somebody is repeatedly buying, and it's not an abnormal purchase pattern, they're buying some products every 3 to 5 weeks, and they're consistently buying it, or maybe they're buying more of it over time, that's a pretty strong indicator that they like this thing. Now, if they buy it and they return it and then buy a competing product within that same product category a short period of time later, that's a pretty strong indicator that they hated that thing. So you can do some very interesting thing with implicit by saying, I'm going to start with a baseline score of any interaction is let's say it's 100 points. If they return that thing, then their baseline score for that item is going to be a negative value because they truly hated it. If they spent time looking at it, multiple times browsing that item, and then they purchased it and they repurchased it again in a short period of time later, you can start saying, okay, I'm going to boost this score that this person has to this product because they really like it. And provided that this continually there's this consistency that happens across all product interactions, You can create formula that combine viewing, adding to cart activities, purchasing, repurchasing, and even the negative things, which is like, hey, they returned it or they put a stop payment on this on some recurring subscription. If you can get the data with customer service that links back to a particular purchase and an item, if you can de-weight that affinity that somebody has because they complained about the product, then, as long as that's consistent over time, you can have a pretty robust model and algorithm that you're using to determine what that implicit rating is now tunable, provided that you have that rule-based system in place.
Yeah. So what algorithms perform successfully in recommendation setting?
Non-negative matrix factorization, usually for explicit. And I mean, I've helped people with FP growth algorithms, which is, it's that market basket analysis, which is, hey, for this particular customer over a fixed period of time, here's all of the products that they purchased. And you build that for every single customer. Like, hey, what was your last 50 purchases or last 30 or 20 purchases? Let's represent that as a market. Or you can do time-based stuff. And those are your antecedents. And your decedents that you're going to get off of that is compare the products that person purchased with things that other people purchased, and what are the differences between those groups, and how frequent does that occur across your entire customer base? So you can say, hey, people that bought these things also bought these things. That's how that gets populated on a website, is that algorithm. It's a little bit more complicated. It's much harder to tune, which is why I never recommend people build one of those first, because you need basically the same data for both algorithms, but ALS or matrix factorization is going to be far easier to implement.
Got it.
Hey, folks, if you love this podcast and would like to support the show, or if you wish you could listen without the sponsorship messages, then you're in luck. We're setting up new premium podcast feeds where you can get all of the episodes released after Christmas 2020 without the ads. Signing up will help us pay for editing and production, and you can go sign up at devchat.tv/premium.
Yeah, a while back, just for buzzword leveraging about reinforcement learning in a recommendation setting. And I was wondering then if you've ever seen that be successful, because the general premise is essentially create a user model and throw different types of predictive models into that user model. And the user model will return selections of pieces of content as well as like key metrics. And then you can use that user model to train whatever model you're actually building. Have you seen that framework work?
I've seen or recommenders work really well as blog posts, like really well. People are fascinated by that. I'm fascinated by it. I read them. And I think that it's super cool. I have not seen a lot of companies that are putting stuff on a website are doing it with deep learning, just because it's expensive, it's complex, and the engineering aspect of it becomes rather daunting when you have to maintain it over time. Which isn't to say that people aren't using deep learning, probably hundreds of thousands of implementations that are out there. But to power a recommender on a website, it's generally going to be, one of the tried and true. If it's something that your company is money off of, and it's a very important that this thing just works, generally companies want to go with something that's been proven.
Yeah, that makes a ton of sense. And also that's just cheap and fast, like in the real world. Well, yeah, fair.
ALS is not cheap to train.
Yeah, that's a good point. But yeah, it's important to remember that in the real world and not in blog post world or academic world, that you actually have to pay for stuff. So when that happens, simple, once again, is very attractive.
Yeah, I think as data scientists, we like to think of the cost of ownership of a particular implementation from the perspective of, okay, how long did it take to train the model or write all the code to get up to that point? And that's a certain amount of cost. And then business, people that are more senior in a company or people that have been around long enough, they're like, well, don't forget to add in the cost of everybody's salary that worked on that. And also the potential loss of revenue. And all of that's true. But there's another hidden cost with complexity in ML in particular, which is maintenance cost. The amount of burden that is being placed on the team over time. If something is successful and working well in production, it's making the company. If something goes wrong with that, you better bet that everybody is going to stop what they're doing to fix that, regardless of what they were working on. They could have been working on their next really exciting, fun project, but hey, projects went down. We don't know why the model is producing ridiculous results.
Look at this.
And, start producing fallback logic, which we know is not that good. So that's when you get executives walking down into the office area and saying, hey, what's the status? When is this going to be back up online? It's a lot of pressure. Is that something that seems like it's going to be really cool and cutting edge and exciting to work on when you're doing the initial development of it? How cool and exciting is that going to be in production if it's breaking all the time? I can answer that.
Point.
It is
exciting at all.
And it's demoralizing. I've seen DS groups that build something like that, deploy it to production. They end up getting so frustrated at the fact that they can't do anything else other than repair their broken code that you have this mass exodus from the company of all the people that built that project. I don't know if it's due to shame or frustration or whatever it is. They just leave. And then you have people holding the bag of this broken code base and this broken implementation. They'll either hire a consultant to redo it or fix it, but it typically ends in regret. Unless you have a huge infrastructure. If you're working for Meta and you have a PyTorch implementation for a recommender for content, of course they have that. But they also have thousands of engineers that can support that and the infrastructure to detect problems and autonomously kick off retraining. And they have, visibility into explainability of what's going on with anything that they deploy. So most companies don't have that because that stuff is expensive.
Yeah, could not agree more.
All right. I think we've been talking for quite a while this episode. This has been a fascinating discussion. And we're definitely going to have to revisit part 3 of this at a later date about what does look like for part 2. We didn't really talk too much about that, about serving something like that, because it's very different than that first part that we were discussing. When you're doing at-scale recommendation serving, you're now talking about REST APIs that can support scalability of that prediction infrastructure or serving infrastructure. And we're not talking about OLTP anymore. If we're talking about e-commerce recommenders, we're talking about NoSQL. But that's a big discussion.
Yeah, agreed. And we also didn't even get into embedding, which is a whole other... there's so much in this topic. We could have a podcast about recommendation engines, but
definitely
for a later date.
All right. So till next time, I'm Ben Wilson.
And Michael Burke.
And we'll catch you all on the next one.
Thanks, everyone.
Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CACHEFLY.com to learn more.